This lesson is on factoring by grouping. When you factor by grouping, the first thing you always want to look for is to make sure that there isn't a GCF that you can pull out of all the terms first. Once you check that, then you want to go ahead and group things with parentheses, probably in sets of 2, and look for a GCF that you can pull out of those things that are grouped in the parentheses. You pull a GCF out, and then what you're looking at is to see if the parentheses that remains matches. If it does match, then you're just going to finish up the problem by writing a set of factors. In our first example here, we're going to go ahead and look, is there a GCF we can pull out of everything? There isn't. So now we're going to go ahead and bring everything down, but we're going to put them into groups of 2. So here's my first group, plus my second group, which will be this 28x minus 49. And now we're looking for a GCF that we can take out of this first group. Well, I can take a 3 and an x squared out of both of these terms. So 3 times 4 gives me that 12, and x squared times x gives me the x cubed. So now if I multiplied these back out, it would give me 12x cubed. Then I have, bring down the negative, 3 times 7 gives me 21, and since this already has an x squared, if I distributed here, I'd get 21x squared to match up here. So now I'm looking for a GCF here, and looks like the GCF that I can pull out will be a 7. So 7 times 4x gives me 28x, and 7 times negative 7 gives me negative 49. Now notice the inside of my parentheses match, so we go ahead and write it as one factor, and then the GCFs get combined here to make the other factor. So you just pull the numbers that were just outside, and that would be your final answer. On this one here, I noticed that I can actually divide a 2 out of every term, so that's what I want to first start with, is I want to do 2 times, and then that would be 28xy, and then we would have plus 35x, then we would go 2 into 50 would be 25, and then 2 into 40y would be 20y. So from here, we're going to go bring the GCF down. I'm going to open up a square bracket because I need to have parentheses where I can group the first 2 terms. So here are the first 2 terms grouped, plus, then I'm going to go ahead and group the second 2 terms, 25 plus 20y. Close that up. And now what I'm looking for, I'm going to bring down that 2 with that square bracket. I'm looking for the GCF I can take out of both of these. Largest number I can take is 7, and they both have an x, so my GCF is 7x. 7x times 4y gives me 28xy. And 7x times 5 gives me 35x. We do the same thing here. The largest thing I can pull out is a 5. So 5 times 5 is 25, and 5 times 4y is equal to 20y. Close it up. Now if you look, this one here could be rewritten. So I'm just bring everything down exactly as you see it. But now I'm just going to use that commutative property and switch these 2 terms, because now what you're going to notice is the parentheses inside here does match. So we take the 2 on the outside, we're going to use the factor 4y plus 5, and then the other factor are the 2 GCFs we pulled out, so 7x plus 5. In our final example here, we're going to see if we can divide anything out of these evenly, in which we can't. So now we're going to go ahead and group the first 2 terms, 6x cubed minus 16x squared. And then we're going to group the second 2 terms, 21x plus 56. So I see out of the first one here, I can take a 2 out, and that can be a 2x squared, which would be 2x squared times 3x gives me that 6x cubed. And then I would have 2x squared times negative 8 would give me the negative 16x squared. Then here, it looks like the largest number I can divide out, the GCF, would be 7. So 7 times 3x gives me 21x, and 7 times 8 gives me 56. Now if you look, the insides here do not match. What does that mean? That means that this was actually not factorable, or sometimes we refer to it as being prime.